What's going on, guys? Welcome back to another TensorFlow tutorial. In the last video, we built a simple convolutional neural network, and when we trained it, we saw that there's quite a large gap between the training accuracy and the test accuracy. And when that's the case, we define it as the model is overfitting to the training data. Now, we call the methods to reduce overfitting regularization, and there are multiple methods of regularization. And to just mention a few, you could reduce your model capacity to avoid overfitting. You could also add L2 regularization, dropout, early stoppage, or adding data augmentation. So if you're unfamiliar with these terms, make sure to watch the more theoretical prerequisite videos that I've mentioned previously. We're going to explore all of these methods of regularization at the end of these series of tutorials. But in this video, I just want to show you how to add L2 regularization and dropout to our model. So in this video, we're going to keep it quite simple. The other methods are, in my opinion, best to keep in a separate video to keep the videos more concise. The first thing we're going to do is we're going to, from TensorFlow Keras, we're going to import layers, but then we're also going to add regularizers. And then when we scroll down to our model, we're going to add, first let's add L2 regularization. And what you got to do here is that you got to actually add it for each of the layers separately. And then, so for simplicity, let's also do padding equals same. And then we got to do kernel regularizer, regularizers.l2. And then we're going to set the weight of the regularization for that specific layer. So let's set it to 0.01. And then we got to do that for all of the layers. So in this one, let's also do padding equals same, just for simplicity. We're going to do kernel regularizer equals regularizers.l2, 0.01. And then we just have one more conv layer. So we're going to do similarly here, padding equals same, kernel regularizers regularizer equal regularizers.l2, 0.01. And then let's also add it to the fully connected layer right here. So we're going to add dropout, but we're also going to add regularization for it. So we're going to use both. Set the same weight. And then in between those layers, we're going to set a dropout layer. So let's do layers.dropout, and then let's set a value of 0.5. So it's going to drop 0.5 of the connections between this layer and this layer. So then let's run X through that. So now we've added L2 and dropout. One thing I want to mention also is that we've added batch normalization, which is the purpose of batch norm is more to normalize the data to have faster training and so on, but it also has a regularizing effect. So a batch norm you could also view as a form of regularization. So really now we're using, I guess, three methods. We're using L2, dropout, and batch norm. So one thing that's when we're using regularization like dropout, it's going to take longer to train because we're dropping a lot of the connections between each of the batches. So what we're going to do here is instead of training for 10 epochs, we're actually going to run it for 150. And then let's see what kind of test accuracy we get, and if it's an improvement from the last training we did in the last video. All right, so training after 150 epochs, we get a training accuracy of 82%, and then a test set of about 74.5%. So it seems that we even need to train it for longer than 150 epochs. But one thing we can at least see here is that in the last video, we had about 93% training accuracy and 72% test set. In this case, the gap between them is much lower, right? The range has decreased quite a bit. And I think that if we train this for longer as well, the gap will get bigger, but the difference is going to be, we're already seeing that the generalization to the test set is better, even though the training accuracy is quite a bit lower than in the last video. But anyways, this video was quite of a more simple and quick one. just showing you how to add L2 and dropout regularization. And we'll explore more ways of adding regularization in future videos.